In this session, we are going to learn about PIC microcontroller 16F877 internal timer 2 module. Learning outcomes. At the end of this session, students will be able to describe the timer 2 module and its features for PIC microcontroller 16F877 and describe the timer 2 operation block diagram of PIC and its application. So these are the contents of today's session. Now let us begin with the features of timer 2 module of PIC microcontroller 16F877. So timer 2 is 8-bit timer only. It operates as only timer, not as a counter, and its count value is 8-bit. It internally contains some readable and writable registers like timer register, timer 2 register, and a period register, which are readable and writable registers. So timer 2 module has a software, a programmable, prescaler, and postscaler. So internally it contains a prescaler in the input side and postscaler at the output side, which are software programmable. Timer 2 module uses internal clock for its operation, as it is working as only as a timer. It generates interrupt on a match. When match occurs inside a timer 2 between the contents of period register and timer 2 register. Timer 2 is an 8-bit timer with a prescaler and a postscaler. It can be used as a PWM time base for PWM mode of CCP module. So the output from timer 2 can be used to provide a time base for the working of a CCP module in pulse width modulation mode, as well as timer 2 supports the operation of synchronous serial port modules, SSP module. So the output of timer 2 can be used by the SSP module for generation of a baud rate clock for serial communication. Now let us think about timer 2 operation. The input clock signal, that is the internal clock signal, so that is derived from system clock, system oscillator. So it is basically system clock frequency, oscillator clock frequency divided by 4. So at the frequency of machine cycle, so the clock signal is provided to the timer 2, so which is prescaled from 1:1, 1:4, or 1:16. So the F oscillator divided by 4, the system clock frequency divided by 4, that is at the machine cycle frequency, the clock signal is divided by certain factor like 1, 4, or 16 by using a control bits from timer to a control register, that is named as a T2 con register, using the bits T2 CK PS1 and T2 CK PS0. Using these two bits, the input clock frequency can be prescaled. The 2 bits prescaler is used for dividing the input clock frequency. The timer 2 module has 8-bit period register. So that is named as a PR2, that is nothing but a period register 2. It is again 8-bit register. Timer 2 increments from the initial value 00 until it reaches to or matches with the content of period register PR2, then resets to 00 on the next increment cycle or in the next machine cycle. So period register PR2, it is a readable and writable register. So the PR2 register is initialized to FF after a reset. As well as we can program a period register as per our requirement. So depending upon the time required to generate output from timer 2. The match output, whenever timer 2 register, TMR2 register contents and period register PR2 register contents equals, it is passed, it generates output from timer 2 output goes through 4-bit post scaler. So timer 2 uses a post scaler, that is a 4-bit post scaler, so which gives 1:1 to 1:16 scaling inclusive to generate a timer 2 interrupt. So whenever match occurs, the signal is passed through post scaler, and to generate a timer 2 interrupt latched in a flag bit timer 2 TMR2 IF timer 2 interrupt flag in PIR1 register, peripheral interrupt register 1 register. So the status bit, interrupt status bit TMR2 IF is set. The post scaler counts the number of times TMR2 register, number of times the TMR2 register matches with period register, PR2 register. So this helps in counting applications where almost 16-bit timer is required with interrupt on overflow. So using 8-bit timer only, TMR2, we can use the 16-bit operation. We can perform 16-bit operation without changing the initial value loaded in period register and TMR2 register, as well as frequency, input clock frequency. With the use of post scaler, we can increase the capacity of timer 2 register. So post scaling is equivalent to count a number of overflows, not in software but in real time. So in this way, with the use of pre-scaling, input clock frequency pre-scaling, and output is post-scaling from timer 2, makes the capacity of timer 2 equal to 16-bit timer counter. So timer 2 can be shut off, turned off by clearing the control bit TMR2 on in timer 2 control register, that is T2 con, at bit position 2 to minimize the power consumption in a PIC microcontroller. Now these are the registers used for programming of timer 2. The registers required for programming of timer 2: INT-con, interrupt control register. So to enable a global interrupt enable bit and peripheral interrupt enable bit, INT-con register is used. PIR1 register, in which the status of timer output is stored, TMR1 IF is stored in PIR1 register. And to generate an interrupt from timer 2, PI1 register is programmed, peripheral interrupt enable register is programmed for timer 2 interrupt generation. Then the load programmable 8-bit value in for counting purpose, that is a TMR2 register, it is 8-bit register, and period register, PR2 register, and to control the operation of a timer 2 register, T2 con register is used. Now this figure shows a block diagram, bit format for a control register of timer 2, T2 con. So bit 7 is not implemented, undefined. Next bits are used to program post scaler 1:1, 1:2, 1:3 up to 1:16 post scaling. And next 2 bits are used for, least significant 2 bits are used for pre-scaling 0, 0, 0, 0, 1 and 1, 0. That is the divided by 1, divided by 4 and divided by 16. and bit 2 of this control register that is used to turn on and turn off timer 2 module. So this figure shows internal functional block diagram of timer 2 in PIC microcontroller. So input clock signal, that is from a system clock divided by 4, it is prescaled using software programmable prescaler. So it is given to timer 2 register. Timer 2 register is incremented and its value is constantly compared with a period register, 8-bit period register. Whenever match occurs equals, the output is generated. So that output is passed through software programmable post scaler before it generates a timer 2 interrupt, TMR2 IF in PIR1 register. So before that, the output from timer 2, so that is provided for SSP module for baud rate clock generation as well as for PWM mode, CCP module. So these are the references. Thanks.